students. We are going to start partial differential equation, and this video is going to be only introductory video, but I will try to cover all the important concepts in partial differential equations. Okay, so let me just start. What are the partial differential equation? Okay, let me assume that z is a dependent variable and x and y is independent variable. Okay, so there are some, I'm just trying to introduce what are those partial differential terminologies. Okay, so x, y are independent variables. Okay, now first order partial first order partial derivatives. So we will basically understand what is the basic definition of linear PDE of first order, linear PDE of second order. How do you distinguish them? So first order partial derivative. Sorry, not derivation, derivative. Okay. Now let me call it P, which is del z by del x, right? And then other one is Q, which is del z by del y. By the way, this you must have understood in your 12th or during your JEE preparation, that when you take partial derivative with respect to x, y is constant. When you take partial derivative of z with respect to y, x is constant. Now you will get a function. This is your PDE, right? X, y, e, q, and z also, of course, is equal to 0. This equation is what? Your PDE, right? So this is the first order partial differential equation that you can find. So this equation is your first order PDE. First order PDE. Now tell me one thing. Is it linear PDE? How will you know? So its basic fundamental is when this equation is linear in P and Q. Okay, so when this equation is linear in P and Q, what do you mean? So these two derivatives should not be multiplied or squared like that. So let me give you an example of PDE. By the way, why do we study PDE? I forgot to tell you in the beginning. So there are so many physical systems that you model and then you find solution to that equation. When I say model that physical system, I mean what those parameters that physical system depends on. So you find a relation between some of the parameters that affect that system. Okay, then you try to find the solution which tells you how that system behaves, how that physical system behaves. Okay, you try to find more. Okay, now so for example, so this equation is linear in P and Q, so we will say that it is linear PDE of first order. Okay, let me give you an example. So example is this. I hope you can see. So this ut plus alpha ux. By the way, this you can you write either zx, zy, these things. So zy will denote this and zx will denote this. So similarly, ut is a time derivative of partial time derivative of u and partial space derivative of x is equal to 0. This is linear in this. Let's say this is p and this is q, so they are linear in p and q. Now this is transport equation. Okay, this is transport equation. Okay, similarly I'm going to tell you a lot of equations that are used in used to represent so many physical systems. For example, transport equation, it is used to represent transport phenomena. Okay, simple ones. Of course, complicated transport phenomena are going to be even more complicated. Now tell me one thing, what is second order PDE? So if I'll ask you second order PDE, then there is going to be three more terms. Let me call it R. So R is going to be del 2z by del x square. S is going to be del 2z by del x del y. By the way, I'll talk about more whether this is symmetric. del x, del y, or del y, del x is symmetric or not. For now, I'm going to just take s is equal to this, and t is del 2 zy del y square. Okay. Now you will get a function of x, y, z, p, q, r, s, t. Okay, is equal to 0. So this is second degree, second order PDE. Okay, second order PDE. Now again, okay, so now this is the second order PDE, but whether it is linear or not, how will you know? When this equation is linear in P, Q, R, S in T. Okay, so like in previous case. What are the examples I can tell you? So first is ut is equal to uxx. What is this? One dimensional heat conduction equation. This is one dimensional heat conduction equation. Okay. What is this? Laplace equation. What is, by the way, this is very famous, you must know. Uxx plus u. So this is Laplace equation, right? Second order linear PDE. Laplace equation. Just one more example and then we'll end this video. utt is equal to uxx. This is one dimensional wave equation. Okay, one dimensional wave equation it is. It is second order PDE, by the way. Okay, so thank you so much for watching the video. I will introduce or I will discuss in detail in more other concepts, and do subscribe to the channel. Thank you.